you can apply KCL at this node. And when you apply KCL at that node, you're going to have a current source which will branch out. Branch out to where? Branch out to inductor 1, inductor 2, and inductor 3. Okay, so the IS will be equal to I1 plus I2 plus I3 and so on. Okay, so this is the one. And then since current source here, the voltage source here in parallel with all inductors. So meaning to say voltage across L1, L2, and L3 shall have the same voltages. Okay, I cannot remove that. Okay, so V source will be equal to V1, V2, V3, V4, and so on. So you know that the current is equal to integration of 1 over L first, the constant, and then the Vs, and then the D. So, and then this is current. And then this V source here, you can put it, since it is equal to the V source, V1, V2, V3 equal to V source, then you can put it at one part. You can combine, not combine, you can put it at one side. And then this L1 in parallel with L2, in parallel with L3, you can use a parallel rules, and this will be equal to L equivalent here. So L equivalent is equal to L1 parallel with L2, parallel with L3, and so on, if you have numbers of inductors. Okay. Next, what if inductors in series? You have a current source which is same across throughout the L1, L2, and L3. So if you apply KVL, KVL around the loops, then you will have a voltage source here, which is equal to V1 plus V2 plus V3. Okay, this equation. And then since current sources are all same across these elements, then you can put at one side the dI dt, the voltage equal to dI over dt. Don't forget the L there. And then this is voltage for inductors. And what we can say that this summation of all inductance in series is equal to the equivalent inductor. So you can put L1 plus L2 plus L3 plus with numbers of inductors in series. So if you want to summarize, the inductance in series or inductance in parallel will take the same rules as the resistor. Okay, same. Then if you want to use a voltage divider or current divider, then what happened? Okay, let me have that slide. Okay, so this is a voltage source. You have inductor 1, inductor 2, some voltage drop across inductor 1, and some voltage drop across V2. Then V source will be V1 plus. V1 will be equal to, you need the V source. Since the inductor will have the same rules as resistor, then you just follow the voltage divider for resistor. And then cross S1 as a L1. And then whatever in series of this L1, you should plus it together. So L1 plus L2. And what about the sign? You look at the positive sign here and positive sign here, you have a positive. So far, is it clear? Brothers and sisters?
Yeah.
Yes. I like you guys to respond because my internet sometimes are not good. like 8:30 class this morning, I got kicked by this internet connection. Then yeah, quite several times. Okay, there's someone just come in. Okay, go back to the slide. So V2, okay, can you give me the answer? V2 is equal to what? Yes.
VS. Bracket.
Voltage 2 drop at L2. Yeah.
L2.
Then this one?
L1 plus L2.
Yeah, very good. And then the sign?
Sine.
The sign, positive or negative?
Positive.
How do you know? You look at the positive sign here and positive sign here, these two. So this one should be a plus. So please be careful for your final. Maybe the question will ask you the simple voltage divider, but sometimes they will trick you in the sign because voltage divider or current divider will not tell you the sign. Okay, this sign you need to figure out yourself. Is it a positive or negative? Okay, let me give you the current divider. Sorry, this one should be inductor. L1 and L2. This is the current source. This one small letter, and this one I1 and I2. I1. Maybe I should change the direction like this. Okay. What is I1 equal to? You need the current source. And then this one will follow like a current divider for a resistor. Then if this one flowing through L1, then you need the opposite one. So this one should be L2. And then divide by anything in parallel, the elements in parallel. So you have
L2.
Yeah, plus 1 and 2. What about the sign? This is going up and this is going down. Meaning to say this one, the current source will branch out here. So yeah, it should have a positive because it follows the current direction of this. And then I2. What is I2? You need the?
IS.
Yes, IS.
L2. L1.
L1.
L1 plus L2.
L1 plus L2. What about the sign?
Negative.
Because this is going up and this is going up, then you should have a negative sign there. Okay. All right. I think all of you do understand this. Just want to repeat again. Under DC condition, you should have how it looks like. Under DC condition, inductor will looks like what? A short circuit or open circuit?
Short.
Yes, short circuit. How do you remember this? You can pull out these two ends apart, right? Pull that things apart and then you will have like a short circuit. This. So even though the inductor is still there, physically it's still there, but it behaves under DC condition, it behaves like a short circuit. And then the current is still there. So you need to write down the current for inductor like this. You replace with a short circuit and then you write down IL. And then what about the capacitor? Under DC condition, what happened to the capacitor?
Open circuit.
Yeah, open circuit. You need to replace with a open circuit because why? Because when you pull these two ends apart, and then you will have a open circuit like this. But please remember to put what? To put the voltage source. Not voltage source, the V drop across that. Because physically, yes, the capacitor is still there, but But under DC condition, it will behave like an open circuit with some voltage drop across this VC. So this is very important. Okay, Alhamdulillah, we finish our chapter 5. Do you have any question before we go to our chapter 6? Chapter 6 very important. Yeah, everything important. I always tell you everything is important. Do you have any question? Shall we proceed to chapter 6?
Yes, I think so.
Okay, let's go to chapter 6. Okay, chapter 6, this is AC. This is all about AC. And then we sometimes say it for under steady state analysis. So what is steady state analysis? This is a time dependent. We have some function. Usually we have a current, signal current, and then signal for voltage. So sometimes we put it in this form or this form. It depends on the time. Okay, so phasor have three way of represent this. I will let you know after this, but the main idea is that when you want to have AC, you need phasor form. So there's 3 types of phasor forms, and then only under AC condition that the capacitor and inductor will be working properly. So you need to understand how this thing behave under this AC. And in order to solve the question in AC form, you need the phasor. And when you use phasor, you have three way of represent this in phasor form. Okay, overview for this. Okay, steady state analysis always have something like a sinusoidal, because why? Because it depends on time here. And then sometimes this one is a current or voltage, a signal. And this one can be represented in this form, or later I will explain on this. And then you know that phasor have 3 forms. And then how you going to relate this with a circuit elements? And then what is this thing in terms of impedance? And you know that impedance is represented with Sect like this, a Z. And then what is admittance? It is a reciprocal of this. So this is admittance. And then there's some analysis. If you look at our first slide here, we have chapter 9 and 10. This one is in your textbook. And then chapter 10 is this part, phasor analysis. What is this? Basically, you already learned this in chapter 1, 2, 3, 4, up until chapter 5 almost. Yeah. This is something that you already apply, the methods you know, like mesh analysis, nodal, voltage divider, current divider, and superposition, source transformation, and so on. Okay, so you're going to reapply this using phasor form. So it's quite lengthy subject, but inshallah we're going to finish it before 3 weeks. So this is week number 10. We have another 2 weeks, inshallah. Okay, so what is this? Okay, before that, before we start, what is this part? Is it a DC or AC?
DC.
DC. How do you know? Majority say DC. Do you agree DC, or do you think that this is AC? Since nobody answered, only one, so I think most of you, majority said this is DC. How do you know this is as a DC?
The shape.
The shape coming from where? This one? Is it this one?
The
Oh,
circle shape.
oh, this one, this symbol there. Okay, okay, all right. Okay. Yes, sometimes we put it this way, and sometimes we put it this way, right? This is AC, this is a DC. But if you look at your final paper or past question paper, usually they will not put in this form. Okay, there's none such thing. Either this is a AC or DC, they will use this form. Okay, so how do you know this one is actually a DC? Okay, for your final paper, you need to look at the value, right? So if you have like VS and then they put it 10 volt like this, then you need to know that a 10 volt is actually a 10 across or throughout the time here. Okay, so meaning to say this is a DC. It will give, in ideal case, it will give exactly 10 volt. It will not give a plus minus of 0.1 or so on. And then how do you know this is a AC or not? Then you look back at the V source here. Sometimes you put it as a maybe amplitude, and then sometimes they put a sine wave, and then maybe omega something. Or maybe later on you will look at the phasor form. Phasor form, there's 3 types of represent this. And straight away you know that this is an AC if they put in terms of phasor form. So please be careful. Look at what they have here. Okay, let's test you on the DC part. So you have this circuit. Okay, under DC condition, what happened to the capacitor here?
Open circuit.
So you're going to represent this as an open circuit. This is open. Okay, so do you think that we can solve this or not? If we have a 10 here, and this one will become like this, right? A V plus minus like this. And then this is with respect to the time. If we have, if not, then because the question asks you on this, determine IT and VT. What is I here and what is a V here? And you know that the current for open circuit is equal to? Current for open circuit will be equal to?
0.
Current will be equal to 0. The voltage here, yes, if you are not considering with respect to the T here, then this one will take the 10. V is equal to 10. Okay. But in order for the capacitor to fully function, with respect to the time, what I mean is if you have a cross throughout all the time T here, then you need to apply this sinusoidal waveform. Okay, can we zoom in this? Tak apa. So we use this one. Okay. You can see this clearly, right? Kalau tak, saya kena kurangkan sikit.
Clear, madam.
Yeah. Okay, alhamdulillah. Okay, you look at the sign, the signals. So this is signal V1, and another one, the dotted lines here, signal number 2. Okay, so the V1 here, signal number 1, it starts from 0. And then, it has this form. So if it starts from 0, then this one will have a sine wave. Yes, right? You already learned this in your math class. So what is VM here? VM is actually the amplitude. Okay, this is a VM. And if I because later on you're going to learn this in your lab 1. This is from peak here to another peak here. So this is a V peak to peak. V peak to peak is equal to 2 Vm. Okay, we have double Vm because this is Vm number 1 and this is another Vm in negative side. So you have 2 Vm. Okay, and then what is omega here? Omega is the angular frequency, which is equal to what? Omega equal to 2 pi f. I think you know this from your math, right? And then the frequency is equal to 1 over t. But what is t? T is a period. And then a period of time is where it is starting from the wherever the signal start from until it ends at the part that it begins. So it starts from 0 here and it should end at this point. So this is a one time frame, or we call it a period of time. And then you know that t is equal to 1 over f. Then if you rearrange this, then you will get some, you can relate this with whatever that you like. So yeah, from this part, you can have like 2 pi over angular frequency like this, or you can have in terms of frequency also can. And then there's another thing, we call it as a phase. A phase is when you have something like it start from not 0. So meaning to say maybe it start from here, from this part. This is at 0. And then if you have it on the left side, then you have a positive. And then if you have it in the negative or on the right side, then this one is a negative. So what does it mean? If you look at the sign here, this one, if you start from here, you can say that this one is a Vm cosine omega t. Omega t. This is a cos. Okay. But if you want to relate it with a sign here, then this plus theta here is actually on the left side. Okay, that's why I put it as a plus here. But if the signal start from here like this, then this V3, a new signal here, is equal to a Vm sine omega t with minus theta. Okay, so this is a minus. And then this part is a positive. So far so good, because you're going to compare. If you're going to compare 2 signals or 3 or more, then you need to have some condition that you need to observe. So what are they? Okay, look at the second part here. Only 2 sinusoidal value with the same frequency can be compared with by the amplitude and phase difference. What does it mean is that if you have maybe the first one Vm and then sine omega t and plus with some phase, and the second one is Vm cosine omega, this is omega 1 and this is omega 2 with some theta 2. Okay, like this. So what you need to observe is on the, maybe I should put this way. You need to observe this sine or cosine part. You need to have both same in order to compare these 2 signals, V1 and V2. So since we have a sine and cosine like this, yes, you cannot compare. And then another part that you need to observe is the frequency. omega is equal to 2 pi f. So that frequency of 1 and 2 shall be same. So make sure this W1 and W2 equal. Alright, so how to compare then? You have a sine and cosine different signals. This is where you going to apply what we call it a condition. Kejap, let me give you this. Okay, and you have a sine here and cosine. By the way, for your what we call for your class, you always will convert it in cosine form. Okay, this is a desired form, a cosine form. So what should you do? You need to have a cosine, but okay. Am I still online? Yes, okay. Okay, let's go back to this one. Okay, so in order for you to convert from sine to cosine, then you have to minus with 90 degree. From sine to cosine, you need to minus with 90 degree. And this part is actually a minus sine, and this part is a minus cosine. Okay, if you want to convert from minus sine to cosine, then you need to plus 90 degree. Okay, so for you guys to understand this, you just memorize only one part. Maybe the negative 90 degree here. So up to you, which one. As long you take the anti-clockwise direction like this. Okay, so please try your best to memorize this, but I think you don't need to memorize because this is an open book final exam, so you just refer back to your notes. Okay, all right, let's go to example 1. This one clear or not? Maybe if you are not clear, maybe I give you one example. V1.
Madam,
Yes.
memang dia punya cosine dia macam tu kan? Dia punya
Yeah. Yeah. This is, I'm not sure you learned this one from your math class or not. How to convert this into cosine form. Okay. Okay, let me show you one example. If you have a sine here, then in order for you to convert this to cosine form, then V1 here will be equal to Vm cosine omega t. And then since sine here to cosine, you need to minus with 90 degree, then you just put a minus 90 degree here. Is it clear? The minus 90 degree here. Okay. What about if I have V2 equal to Vm? Maybe negative sine omega t. What should you do? This is a negative sign. So this is negative sign, right? So what should you do?
Plus 90.
M cos
Okay.
omega t plus 90.
Yeah, you need to plus 90. And this one already changed to cosine. Okay, very good. Okay, go back to example number 1. Given is a sinusoidal form and calculate its amplitude. You don't need to calculate amplitude. So what is amplitude? From here?
5.
Why?
Okay, 5. If I put it as a V, then this is a V. If this is a current, then 5 amps. What about phase?
Negative 60.
Okay, very good. Angular frequency?
4 pi.
4 pi. Yeah, I forgot to let you know that the unit for angular frequency is in radian per second. Okay. And then what about T, period? How do you find T? 0.5 macam mana tu? What is the equation then? You know that omega is equal to 2 pi f, and then the t, yeah, and you know that omega is equal to 4 pi, and this is 2 pi over t, right? So you can play with this. T is equal to 2 pi over 4 pi.
Oh,
Yeah, this is 0.5 second. Since there's no unit, then I just put second without prefix. What about frequency? Frequency?
1 of
2
2 hertz.
2 medium.
0.5
2.
and 2 hertz. Okay. This one clear, eh? Just to make sure that you know how to read the signals. Okay, I think this is clear. What about phase angle? Okay, you need to find phase angle between I1 and I2. Does I1 lead or lags? This is what I said, that you need to compare two signals. Okay, so before you compare, what are the two things that you're going to check? What are these two things?
whether the value same or not.
The sinusoidal, the signal for one sine or cosine same or not, right? So this one, it should be same. And then this part, right? Okay, what about the second part? The second part is, what should you compare? What are the two things that you need to look at first before you compare two signals?
Omega.
Yeah, the angular frequency. Don't say omega. Omega, I think it's in your math class, but this is angular frequency. Since this is 377 for these two, then you can compare that. But before that, we have a sine wave here, right? So you need to convert. I1 here is equal to -4 sine 377t plus 25 degree. So in order for you to compare with this cosine, you need to convert this negative sign to cosine. So what should we have here?
Plus 90.
Okay, plus 90 degree. So this one will be equal to?
Sine.
115.
115 degree. Okay, don't forget the degree. Okay, now can you compare? Can you compare now? Yes, right?
Yes.
Same. So you can compare. All right. All right. How to find which one is leading and which one is lagging? Maybe I shall remove this part so that we have some space. Okay, let me draw the first signal. The first signal is a plus 115. And if you look back at your this part, maybe I cannot remove. This is the plus, right? This one. A plus on the left side and the minus on the right side. So go back to the question. Since this is a plus, then it should be starting from left side. So this part should be 115. This is a plus, this is a minus, right? So
Yes.
you can draw any waveform, maybe something like this. And then you have a negative here, negative 40. But before that, maybe you write down, this is signal number 1. And then let's draw signal number 2. Signal number 2, because I want to have a black color, that's why I put it like this. And this is 40. This is negative, this is positive. Okay, let me make it bigger. Okay. So we have I2 on the right side. We start from the right side. Then what is this theta? Hmm?
155.
Plus 40, then you get 155 degree. So which one is leading? Can you guess?
I1.
Because the signal comes first, right? So I1 leads I2 by 115 degree. Okay, this is how you write down. Or you can say I2 lags I1
I1.
by,
155 degree.
yes, 155 degree. Okay, do you have any question here? What to look first? This one, right? 1, 2, and these two signals are comparable, and then you can draw the waveform. And from this waveform, then you can figure out which one is leading or which one is lagging. Just one. Maybe you want to say in this way. Then
Madam,
yeah.
tadi macam mana nak tahu yang mana positif, yang mana negatif graph?
This part, basically, if you look back at this one, okay, I want to remove, and you look at this V2. V2 is equal to Vm sine omega t plus theta, right? This plus theta here is on the right side. It starts from the right side, left side. So this is the theta for on the plus side. Okay, it starts from left side. Okay, so you just have it from here. I think this one, why they have a plus sign here? Because they use the rules of cosine to sine wave. But since because the instructors, the coordinator for our electric circuit ask us all to use in cosine form, then you need to put it in a cosine form, not the sine form, not the sinusoidal form, sine wave form. So you need to have a cosine form. If you look at your textbook, maybe they use in sine wave. Basically, as long they are same, then you can compare. Okay, sine and sine, then you can compare. That's why they put this one only, this one omega t, without a plus 0 because it starts from 0. But if you put it in a sine wave, then you need to plus some theta there, and that theta is the plus sign is actually starting on the left side. Okay, is it clear? I think you just need to remember on the this plus on the left side, minus on the right side. Maybe you guys learn it from the math class, different way to figure out which one is which one. Maybe sometimes you can use this form. This is a I1 maybe, and then maybe another one is I2. So you can figure out maybe this is like this. This is 150, and then the I2 maybe starting from here, 40 degree, like this. So this is I1, this is I2. So these two is equal to 155. It depends on you, which one you prefer, but I like to have it in this way. Okay, maybe this part you are familiar in your math class. So up to you. Right, do you have any question before we move to the next phasor part? Any?
Oh,
No? Okay then. Okay, this phasor. Phasor is a complex number, okay, complex. it represents amplitude and also phase of a sinusoidal. Meaning to say, there's two elements that are very important, which is the VM, VM, and also the theta. So phasor have three types. Phasor have three types, 1, 2, 3. One is the rectangular form, rectangular. And then second is polar form. And third is the exponential. Okay, exponential form. So rectangular, I think this one, you know better this one. You have a x plus gy. What does it mean? The x plus gy, the x here is the real axis, and the j here is the imaginary axis. But we just put j there. The element that you need to consider is the x and y. If you draw the imaginary and real axis, you will have this. Sekejap, ada orang baru masuk. The real and imaginary part. So if you plot this, you have imaginary on the y-axis, and then the real axis is the x-axis. Okay, and if you draw this thing, this is the amplitude. The R here is actually amplitude VM. Usually they put it as a V or I, so they don't want to put it some signal form like current or voltage, so they put it as a R here in your textbook. So just follow with that, but you need to know that this is amplitude. Okay, amplitude. Okay, and then the phasor form is that Z, the Z, and X is the real axis, and Y is the imaginary axis. So we have some theta different there. If you apply from your math class, what is R equal to? R is equal to x squared plus y squared, and then under square root all. And then what is theta equal to? Theta is equal to inverse tangent of what? Tentang this y divided by x. So y divided by x like this. So you need to reapply your math class in electric circuit class, something like that. Okay, so far so good. So what is rectangular form? Rectangular form is when you represent this in terms of real axis and imaginary axis. That is the x plus jy. Usually we put as a j here because why? Because we do not want this one to be, yeah, you know that imaginary is I, M, A, G, I, N, A, R, Y, right? So we don't want to put it in I because I for electric circuit is for current. So we want to differentiate current with imaginary, then we put as a J. Okay. But if you go through your, if you use your calculator, okay, do you have your calculator with you?
Yes.
Yes.
Yes, madam.
Go to the mode, and then you look at the complex form. Do you have complex form?
Yes.
Okay, and then can you find degree? Okay, can you find complex and also degree? These two things that you need to set before you use phasor. If you want to calculate phasor, please make sure that your calculator is in this setting, complex and also degree. Okay, I will not teach you on how to use the calculator because I already have a video on that. I will give you that link, and please remind me because sometimes I forgot. And all right, let's go to the second part. We have pola. What is pola? Pola is when you have this thing in terms of, this is amplitude. The R here is amplitude. And then the theta. Okay, theta is the phase. So you have amplitude and phase. If you look back at the definition of the phasor, phasor is a complex number that have amplitude and also phase. So you have amplitude and phase here. But what we can say from rectangular form, do you have amplitude and phase? If you just look at here, it's hard to find that, but you can find it from this form. Okay, the R here, which is equal to x squared plus y squared under square root this 2, and then you have a theta. This R here is the amplitude, and the theta is a phase. Clear, right? So you still have that amplitude and phase. Okay, the last part, phasor, can be represented in terms of exponential form. So what is that? This is when you have amplitude, the R, and then you have exponential, and then you have a imaginary with some theta. Theta is the phase, and sometimes you can have a plus here or a minus here. So it depends. Okay, so you have it like this. Then, or we can say this are the three form. Okay, what is Z? Z is actually the macam mana? Kalau if you put it in terms of a current or a voltage, then this is the Z. Okay, what is R? R is the amplitude, Im or Vm. Okay, so sometimes in a proper way, a signal, any signal, like maybe this is a current, I put a bar there, and then I put a Im bar, and then I put, maybe this is in polar form, then this is the way we write down. So what is I bar? In your textbook, usually they put it in capital letter. Like I said, a capital letter is actually a phasor form. To represent this in terms of phasor form, you need to have, in your textbook, usually they bold this thing and then make it capital letter. So since if you want to write down, it's quite hard to put it in bold form, then you need to have a bar sign here. Whether you put it bar on top of this I or down here, doesn't matter, as long as you put a bar. Or sometimes students just ignore this. It's also acceptable, as long as you have a capital letter. Okay, what about Im here? This is amplitude. Amplitude with bar. In your textbook, usually they put it in Im bold form, and then capital letter. Okay, and theta, yes, you have a degree, normal way. Okay, do you have any question before we move to next slide? I give it real slow because this is very important. How you read this phasor form, then you can answer your question later on. But if you cannot understand this phasor form, then it's quite hard to answer your question. Tak ada? Okay. Euler's identity and complex conjugate. Okay, we go first Euler's. Euler's, maybe you learn this from your math. If you choose exponential with a plus sign, then in a Euler's form, you're going to have a cosine theta with a plus and j sine theta. But if you use e minus j theta, exponential with minus j theta here, then you're going to have a cosine theta with a minus sign and then j sine theta. Okay, I think that one no need to explain. But if you look at this and this is obvious a rectangular form. So this is a real and this is a imaginary. how do you come up with this? This is basically coming from, this is x and this is y. And you have a theta here. And you know that if you want to find the x-axis here, x is equal to a cosine, right? Cosine theta. And if you want to find y, then this one will be the sinusoid of theta. And you need to look at if this is going up, a positive, or going to the right side, then this is a positive. Then you have a positive and positive here. So far so good. Okay.
Okay, madam.
All right, very good. So this is what they explain. Real part cosine theta and imaginary part is the sine theta. But what is complex conjugate? Is this familiar to you or not? Complex conjugate. Complex conjugate usually will have a asterisk form. So let's say you have a signal of x plus gy. This is without asterisk, okay? So if you want to represent this in terms of complex conjugate, then you need to have a z with asterisk, and then the sign form here you need to reverse or opposite this. So x minus gy. Okay. And what about the in polar form? If you have this in polar form, then maybe you have something like this. Then in polar form, this one will be z asterisk r. No, this is amplitude. And then you have to negate the phase. So you have a negative theta there. And then maybe this z in exponential form, you have a amplitude and then e with j theta. Then the complex conjugate will be z with asterisk and re with minus sign. You need to negate that phase and then you have a j theta like this. Okay. Any question? The most important part is the asterisk form. Don't forget the asterisk. Okay. Do you have any question before we go through this? Yeah, we still have like 20 minutes. Okay, for math, operation of complex number, these two are in the same format, which is rectangular form. What are these two? This is a plus and subtraction. Let's say you have two signals that you need to plus. This is signal number 1 and the other one is a signal number 2, Z1 and Z2. Then you have a plus or addition or subtraction. Then the best way, if you're going to use a mathematical operation for this complex number, the best form you're going to use for a plus or minus is in rectangular form. Okay. So the real part you can add and the imaginary part you can add. This is from signal 1 and this is signal 2. Signal 1 and then signal 2. Same as your subtraction. You have a real part you can minus and this part you can, imaginary part you can minus. What about multiplication and division? The best form is in polar form. Okay. And then, ada orang baru masuk juga. The best part is in polar form. So, how to do this? If you have two signals to multiply, then the amplitude you can multiply, but for the phase you need to add. Right? What about division? The amplitude you can divide, but your phase here you need to use minus sign. Okay, for reciprocal, this one quite tricky, but the best way to solve this in polar form. Okay, so what is this? This is basically a z inverse, which is equal to amplitude inverse with a minus theta like this. So far so good. If you have a 2 there, then usually we have some inverse like this, and just go through like this. Okay, what about square root? Square root also, the best way to solve this is in polar form. What is this thing? This is basically, if you have a square root, this means that you have a z with half like this, right? In this form. And then the amplitude, you can do the half like this. And then the theta form, you can divide by 2. Why is it all these formulas are very important? Because sometimes when you use your calculator, usually I will ask you to use calculator. But if you start with your calculator, or you cannot do to solve using calculator, then you need the mathematical operation for this complex number. Sometimes calculator will give you some error because of they cannot calculate the thing using the model that you have. Okay, so what should you do? You go to either one of these 8 form mathematical operations in order to solve this. Okay. Complex conjugate, yes, already explained. And then Euler's form also explained. So do you have any question before we move to the next?
Madam,
Yes.
so we should memorize all the formulas or not?
Oh, no need. No need, because your batch is very lucky. Everything is online. Online and open book. So when you have open book, then just get ready with your textbook or your notes, so that when you have the question, then you can just go straight away to the notes or textbook. Oh, before that, maybe sometimes you're going to have this one in terms of not square root, maybe cubic or anything, right? So what should you do? You can use this formula, but for this amplitude, you can do this part, and then the theta here, you can divide by 3. If this is 4, then you do the 1/4. Okay? This one clear? Alhamdulillah. You guys are very lucky. Alhamdulillah. Okay. For this, actually, in my normal class, I usually ask them to do the mathematical form first and then use calculator. But for you guys, I don't want you to spend time on the mathematical form unless you are stuck with your calculator. So what should you do? Just use your calculator. Okay, tapi I will share you the link for how to use the calculator, and then please try to do this too. Okay, I think they give you the answer. This is the answer. So if you got stuck anywhere, then we can discuss in our next class. Is it okay?
Okay, madam.
But the approach is, just I want to highlight you something. This is like your math class, right? You need to solve in a bracket first, and then the multiplication, and then the division if you have, and then solve everything. So like our A question here, you have multiplication on this side, and then since this is a bracket, right, and then we need to solve inside here, and then do the square root. So, and then you can get the answer of this. Okay. For the second part, I think you know how to do it. Maybe this and this you can solve first, and then division, and then the plus. Okay. Only use this mathematical operation when you don't get the answer using calculator. Or you get stuck with something. Okay, so phasor form will be different from cosine function in all preceding study, meaning in your class, you're going to have a cosine form. Okay. Okay, this one do not need the calculator, but you can use also your calculator. But just want to highlight how you draw this on this graph. Polar form. Polar form, phasor form, sorry, phasor form. So find equivalent expression for the following. You have one. Any volunteer who wants to not draw, but to give it in rectangular form? What is this in rectangular form? The question I have only one there. This is number 2, number 3, number 4. Okay, any volunteer? Because after this, we're going to draw. Volunteer? No? Do you think this? What?
White.
Huh? Come again?
Jambot itu, jambot.
Oh, jambot. Masya Allah. Saya dengar. Ada orang berkobar. Sekejap. Jambot sekejap. Kedok juga jambot because you will know how to draw it. The other section I forgot to share Jamboard. So I draw myself. Ya Allah. Where is the Jamboard? We have like 10 minutes. Okay, tak apa. Kita just pick one or two. Okay, maybe this one. Okay, share. Please go to maybe page number 3. Page number 3. So where is our? Okay. Page number 3 or 4. Okay. 3 already used, 4 also used. Okay, page number 5. Go to page number 5. So we have, let me draw. Okay, imaginary and real. You have 1. What is 1 equal to? In rectangular form. Maybe someone wants to volunteer for rectangular form. Maybe someone wants to volunteer for polar form and exponential. Okay. Very good. But usually we draw this, we write this in terms of 1 plus j 0, not the other way. But because of this is a 0 into j, then we do not need to write down the 0. But how to draw this this form, imaginary and real as this? Where is that number 1? Yeah, betul. Very good. Okay, this is 1. You write down 1 here. Okay, what about polar? Can anyone volunteer how to write down in polar form? Polar should have face, right? Okay, so how to write down this? Do we have theta? Do we have theta?
No.
No, so this one should be 0. Yeah, very good. But what about magnitude? How do you know this one as a 1? How do you know? It comes from rectangular form, right? Amplitude is equal to, just write down, amplitude is equal to 1 square plus 0 square under square root of those. So you have a 1. This 1. Okay, you just need to make sure that this is not a real form, but a amplitude. Okay. What about exponential? You need the exponential there. And then what is the amplitude? And what is the J? Okay, where's the J? Yeah, okay, good. Okay, usually we write down in terms of 1, E, J, 0, something like this. And then what is 1 here? What is 1 here?
R.
The amplitude. Okay, this part and also this part. This is amplitude. So I think you're clear with 1. Right. Let's go to our second example. Maybe 1 with 135. 1 with 135. We go to our next page. 135. 135 degree. This is obviously in polar form. Can you write down this in terms of rectangular form? This is polar. And then also draw the circuit. The graph from imaginary here and rectangular form. And what is in exponential form? Okay, rectangular. Yeah, very good. Ada orang draw a straight line, very good. Polar already there. This is a polar. So how do we draw the rectangular form? Or we draw the polar form on this. Okay, always start with this axis. Okay, this axis. So since we have 135, what should you do? This is a 90 degree. Okay, start with this. We go to here, right? And then we have a 90 plus something. 135 minus 90, what do you get? Hmm? 135 minus 90 degree, you get maybe 45, right? 45. Okay. So write down this one. That's a 45 degree. And this is 135. Can someone draw this one a straight line? Oh, inshallah. Very good. Very straight line. Okay. And then what do you think? What is the amplitude here? What is the amplitude of this? 1. Okay, someone say 1. Okay, write down this one as a 1. Okay, very good. And then your job or your task is to find the x-axis here and also the y-axis here. So what is that x and what is that y? I think someone just bought a pen, a digital pen. Okay, 1 cosine 45 degree. Yes. Is it a positive or negative for real axis? Is this a positive or negative? Negative. Okay, a negative. Okay. What about y here? Is it a positive or negative? It is going up. So yes, positive. Yeah, very good. Okay, you can put it in terms of cosine 45 degree like this, or you can put in terms of square root 2 divided by 2, or maybe 1 over square root 2, I think, equal to this value. Is it right? Okay, you can use your calculator and then write down in terms of this form. Is this correct? 0.71? If yes, then okay, fine. So if not, then you can use this form, G. Don't forget the G. All right. Second, you have EJ135. Is this correct or not? Exponential? Yes, right. We have 1 in front because of the amplitude. Okay, very good. Yeah, we still have 1 minute. Which one you like to try? Go back to example 4. You choose. Which one you like?
Number 5 madam.
Number 5. Okay. E negative J 90 degree. Okay, go to page number 7. E J negative 90 degree. Okay, this is in exponential form. So you're going to write down in terms of polar form, and then in terms of what else? Exponential, rectangular form. Rectangular form. Thank you. How you draw this J with negative 90 degree. Usually we have a positive face, right? So maybe you can start to have the opposite direction. Usually we have a positive on this direction, but since we have a negative 90 degree, then you can have a opposite direction. Please make sure this is 90 degree. Is this a 90 degree or not? Is it a 90 degree? Yeah. Maybe you can use different color to draw the this form. Okay. Anyone volunteer to draw this? Okay, thank you. 90 degree. Okay, what about the amplitude? What do you think the amplitude of this? You can draw like this. Okay. What is the amplitude? 1. Yeah, very good. 1. Yes, correct. And this is negative 90 degree coming from this part. Okay. I better not to put the negative sign there because we already have that 90. In polar form, yes, you have that. Okay. This is one with, yeah, correct. Either you put it in this form or you have it like this. 270 degree. Okay. And this is in rectangular form. What is this in rectangular form? This one apa ni? Cosine negative 90 degree. Is it a real axis? This one? Is it a real axis or imaginary axis? This part? Is it an imaginary axis or real axis? Do you think that we have real axis? I know this is a real axis. Do you think that we have that real axis here?
No.
No, right? There's no real axis because we only have this side. This is equal to 0 real axis. So this one should be 0. So I think cosine negative 90 degree will be equal to 0. Is it right or not? I think so. 0. So do not need to put any. So you should have a 0 here. Plus J. Is it a plus here or a minus? since we say that going up is a positive and going down will be negative, right? So this part is a
Plus.
plus. No. If going up is a positive, going down will be a minus. So this one should be a minus j. Okay, minus j. No, I think what is sine negative 90 degree? Can you use your calculator and find it?
-1.
Yeah, -1. So no, do not need to write down the sine negative 90 degree. You just write down 0 minus j, just that. Or you just write minus j is enough. Minus j. So this is in rectangular form, and the one with polar negative 90 degree is the polar form. Very good. Okay, do you have any question?
Mida.
Yeah.
Yang cos 270 tu boleh pakai ayat?
Cos mana? Oh, to
Yang
70. Boleh, tapi usually we will not use more than 180 degree. We only have like it's better to have like 90 degree or less. Don't put exceed this 180 degree. Okay. If you write down or you use your calculator cosine 270, do you get the answer or not? Cos 270. Is it equal to 0? Okay, if this is equal to 0, then it's still valid, but usually we will not use this more than 180 degree to write down, but it's still valid. Okay, all right, very good. Is there any other question? Tak ada? Ada ke tak? No. Okay. So with that, do you have any other question? Oh, before that, maybe I shall highlight something. Do you want additional assignment or quizzes? Because we, in our first week, we agreed to have only two assignments, I think. Oh no, 2 quizzes. No, saya pun dah tak ingat dah. Maybe 2 assignments and 3 quizzes, right? Do you need more, or you just think that that one is enough for your carry marks?
boleh tambah carry mark.
Carry mark, if you want to add your carry mark, basically you're going to have another quiz or another assignment. And then make it divide by how many quizzes or assignment that you have. Itulah. Oh, now assignment. Okay.
Simon,
Simon edit.
Okay, assignment. Okay. Inshallah. I will look. Maybe for our chapter 9 and 10 we do assignment problem. Or maybe I can give you some poll first, and then let's look and see whether you guys agree to have more assignment. Okay, assignment or quiz. So with that, I think we can stop here. One more thing, last. Chapter 9 and 10 is your question number 4 for your final exam. So this is very important title or chapter, because it is equal to 1 question from your 4 total question in your final. So this is question number 4. Okay, please be prepared, inshallah. And with that, we finish our class with tasbih kafara and surat al-as. Subhanakallahumma bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Al-'asr innal insana lafi khusr illa alladhina amanu wa 'amilus salihati tawasaw bil haqq wa tawasaw bis sabr. Alhamdulillah rabbil alamin. Okay, attendance. Don't forget your attendance. In chat.
Ada.
Ni jam board eh? Sorry. Oh. Apalah. Okay, this one.
Madam,
Yes,
do you have any past question that past year?
I do. Yeah, I do have. Tapi I didn't compile yet. Ya Allah. Yeah.
Not
I will try to compile it. But and then I will give you the time to answer. Yes, you need like 2 weeks before the final, right? Ya Allah.
okay, madam. Thank you.
Okay, remind me later because someone asked me tapi I forgot to compile and then majority from other section also asked me. So please keep on remind me and also remind me on the calculator. Okay.
Thank you.
Assalamualaikum.
madam.
Please scan this and then attendance.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Assalamualaikum.
Madam.
Thank you, madam.
Thank you, madam. Thank you, madam.
Sama-sama.
Thank you, madam.
Madam.
Sama-sama.
Thank you, madam.
Okay. Welcome. Suka dia main Jamboard.